Okay, so earlier we saw how to formulate the differential equations. So now let's see how to solve the differential equations. So we will see different methods to solve the differential equation. Like we will start with the variable separation method, then followed by homogeneous method. Then we will see the non-homogeneous method. Then we will see the exact differential equation and reducible to exact differential equation type of questions. Then we will see linear differential equation. Then we will see Bernoulli's type of like reducible to linear differential equation. So we will see more about it. So let's carry on with our first topic, that is variable separable method. So if you see variable separable method, so what here you can see this general form of this variable separable method type of question. So here what we will do is we will bring the function of y on the side of dy, and the function of x will be brought to the side of dx. So for example, you can see the next step here. So uh, we have brought this the function of y on the side of dy, and we are integrating it, and on the function of x on the side of dx, and we are integrating it. So that's the process we will follow. For example, you can see two illustrations for this. So for example, this dy by dx is equal to 1 by 1 plus y divided by 1 plus x. So in this case we will bring this part which is a function of y in the side of dy. So you can see here we have brought it, and the function of x we will bring the dx on this side. So we have taken dx this side by cross multiplication, and we get this. So now separately we will integrate both side, both LHS side and RHS side. So on integrating the LHS side you will get ln 1 plus y, and on integrating the RHS side you will get ln 1 plus x, and we are adding the constant of integrity that we already saw how to do. So taking one more illustration, for example, this is also a simple illustration. We will see one better question also after some time. For example, dy by dx is equal to e to the power of x minus y. So in this case you can write it like this e to the power x divided by e to the power of y. Then you can take this y on this side, e to the power y, and this dx on this side. Then doing this, now you have to simply integrate both side, both LHS and RHS side. So when you integrate this, you will get the final answer as this. So these were the simple questions just to illustrate the phenomena of variable separable method. Now let's see one problem. So it is a very good problem. You can like try this problem by your own. So I will give you some time. You can pause the video and then you can go with the problem. So I hope that you have tried the problem. So now let's see the solution of this problem. So here we have to carefully see that this is a x plus y whole square formula. So you will write this as x plus y whole square plus 1. So this was the like main thing that you have to find out in this question. Then dy by dx is equal to 2x plus y. Now we will what we do, we will substitute x plus y is equal to t. So this will help us to bring this differential equation in our variable separable method. So we will see how. So for example, if you once write, so here if you see the here, now differentiate this substitution with respect to x on both sides. So you will get 1 plus dy by dx is equal to dt by dx. Now let's substitute it in the parent differential equation. So you will get t square plus 1 times, for dy by dx you have to substitute with this equation. So here you will get dt by dx minus 1 is equal to 2t. So now further simplifying this, you dt by dx you will get equal to, take this on this side, so it will go in the new denominator, and take this minus 1 also on the RHS side, it will add up. So now further simplifying it, dt by dx at denominator take it constant t square plus 1, and in denominator 2t plus t square plus 1. So finally you will see here this is a formula of t plus 1 whole square. So t plus 1 whole square by t square plus 1 dt by dx. So now if you see, if you bring this So this side, if you see, this is a function of t and this is dt. So if you bring this function of t in this side, left hand side, and take this dx on the right hand side, so you will see that you will get dt, sorry, so you will get this term at numerator and t plus 1 whole square term at denominator, and here dx. So now what you can do is you can simply integrate it. So now you can easily solve this, and we have seen that here also we can use our we used our variable separable method. So log integrating it is very easy, but if you want to like control, so let's do it anyhow. So what we will do is we will separate this. So 1 plus t plus 1 whole square dt plus t square t plus 1 whole square dt integral. This side you will get x plus c. So this is also easy, no need to worry, because it will simply give you minus 2 t plus 1, simple, because we are using this formula of integration. So I hope that you are facing it easy, and this we will see how we will do it. So let it be as it is, and here x plus c. So we are just have to find this one. So what we will do, we will substitute t plus 1 equal to z. So dt will be equal to dz and z will be equal to t minus 1 from here. So if you substitute here this one, it will become z minus 1 whole square in numerator, and in denominator you will get z square, and here you will get dz. Further, if you see, let's open the square on the numerator. So z square plus 1 minus 2z by z square dz. So now just further if we solve, this will give you 1 plus 1 by z square minus 2 by z dz, and we know that the integration of this is very simple. Here you will get z plus, here it will give you to minus 2 z, and here you will get minus 2 ln z. So now substitute back the t over here. It will be t minus 1 minus 2 t minus 1 minus 2 ln t minus 1. Now this you have to just substitute this in the parent equation, and like in place of t you have to replace with t as x plus y, because initially we have used this. So then you can get your final answer. So I hope that you have liked this question. So this is a very good question that you can go with. So I hope that you have understood this variable separable method.